Quicksand, myth or reality? We've all seen it in movies. Someone steps into a patch of quicksand, and within seconds, they're sinking helplessly, flailing for survival. But is quicksand really that deadly? Is it a real geotechnical hazard, or just a dramatic plot device? Today, we're going to explore the science behind quicksand, what it is, how it works, and whether it's truly as dangerous as pop culture suggests. What exactly is quicksand? Quicksand isn't a type of sand. It's a mixture of fine sand, clay, and water that behaves like a liquid under stress. It appears solid until you disturb it. When someone or something steps on it, the structure breaks down, and the material acts like a fluid, trapping anything that enters it. It's a non-Newtonian fluid, meaning its viscosity changes under stress. That means the more you struggle, the more resistance it offers. But contrary to the cinematic depictions, you won't be sucked to the center of the Earth. In fact, due to human body density, it's almost impossible to sink completely in quicksand. How does quicksand form? Quicksand usually forms in saturated loose sand areas where underground water is flowing upward. This upward water flow reduces friction between sand grains, making the material lose its strength. You'll often find quicksand near riverbanks, beaches, lakesides, marshes, and even some desert oases. The key to quicksand formation is liquefaction, a phenomenon where water pressure between soil particles builds up, weakening the soil structure. It's the same process that can cause soil to lose strength during earthquakes. Is it actually dangerous? Yes and no. Quicksand itself won't suck you in like a vacuum, but it can trap your legs, making it incredibly hard to move, especially if you panic and struggle. The real danger is not the quicksand itself, but what happens around it. If it's near rising tides, floodwaters, or in remote areas with no help, the inability to escape quickly can turn deadly. Additionally, heavy equipment or animals can get stuck in quicksand areas, making it a logistical nightmare during construction or farming. Real-world occurrences. Quicksand isn't just a movie myth. It's been encountered by hikers, soldiers, and even construction workers in various parts of the world. In 2005, researchers in the Netherlands recreated quicksand and proved that it takes a massive force, like lifting a small car, to pull out a trapped human leg quickly. There are documented cases in places like the Amazon, the UK, the US, and parts of Asia, where quicksand patches form naturally. However, these incidents are rarely fatal and more often result in embarrassment or minor injuries. Geotechnical insights. From an engineering perspective, quicksand zones are unstable and unpredictable. When found during site investigations, engineers must assess the soil's shear strength and water content. Stabilizing quicksand-prone areas often involves draining water, adding gravel, or using geotextiles to reinforce the soil. Modern geotechnical tools, such as cone penetration testing, CPT, and piezometers, help detect high pore water pressures that may lead to liquefaction or quicksand conditions. How to escape quicksand. If you ever find yourself trapped in quicksand, the first rule is simple: don't panic. Stay calm and stop struggling. This reduces suction forces. Lean back gently to increase your surface area. This helps you float. Move slowly and try to lift your legs one at a time. Discard any heavy backpack or gear to reduce your sinking depth. Remember, quicksand acts like a thick liquid. Treat it like water. Spread your weight and use slow movements to regain control. Why it captivates us. The idea of quicksand plays on a deep fear, the ground beneath our feet suddenly becoming unstable. But the real lesson here is not about fear. It's about understanding natural materials and how they behave. Quicksand may not be the instant death trap we see on screen, but it's a fascinating example of soil mechanics in action. In civil and geotechnical engineering, these concepts matter. Understanding soil behavior is the foundation of safe design. From roads and bridges to buildings and dams, engineers need to know how soils react under different forces, including saturation, stress, and pressure. Thanks for watching. If you found this video eye-opening, give it a thumbs up and share it with others who are curious about the hidden world beneath our feet. Subscribe to the channel for more engaging videos on soil mechanics, structural design, and fascinating civil engineering phenomena. Let's keep learning, questioning, and digging deeper together.